So hello everyone. What we are going to do is to implement in an Anylogic model the Excel interface. I have opened the basis model from the previous tutorial. As you can see, I have the one machine model. Agents are generated in the source, stored in the order queue. Whenever the processing station is idle, the next agent can enter the processing station. And in the FGI, all orders are delayed until the due date has been reached, and in the sync, those agents are destroyed. We are going to measure a lot of key metrics here, for example, the WIP and the average WIP, the production lead time, tardiness, the FG lead time, and finally the service level. To start, we have to go to the palette, and then we're searching for the connectivity palette. And here you can see the Excel file. We drag and drop it into our model. I name it Excel results. The next thing we are going to do is we are inserting a variable. The variable is called var Excel sheet name. The idea of this variable is that you can change the name of the Excel sheet where your results are going to be stored. And finally, we need the function. The function is called fun Excel write results. So, and now we can go to our function. You can see here arguments, so no arguments are needed for this function. We will call it when the simulation model is built, but the function body is the important one for us. So in the beginning we are going to initialize an integer parameter for counting the row and an integer parameter for counting the columns. So we start integer actual row is set to 1, semicolon. Integer actual column is set as well to 1, and then we need the parameter maximum column, which is set to 30 in my case. If you want to transfer more than 30 items, you have to change this parameter here. The next step we are going to do is we're searching for the last row in our Excel sheet, because we don't want to overwrite the results in our Excel sheet. We would like to include them or add them in the end of the existing sheet. So for that we define the parameter actual row. Actual row is equal to the Excel interface, which we have already included in our model, Excel results, and we call the function get last row number. Get last row number. And here we have to include the name of the Excel sheet, which is called or which is stored in the variable Excel sheet. And in the end, don't forget the semicolon. So, and then we don't want to write the results in the last identified row, so that means we increase the counter of the actual row by 1. We use plus plus for that. So I need more space for that. The next part is for initializing the new cells in the actual row. For that we need a for loop for integer I is the counter of the for loop, is set to 1, and it should go from I smaller or equal to the maximum amount of columns we are going to synchronize, and I plus plus. Then we open the for loop and we transfer or we generate an Excel cell in our Excel file. Therefore we open the Excel connection, Excel results dot create cell. We need 3 parameters. Sheet index is in our case the variable Excel sheet name. The row index is the active row, and the column index is our for loop parameter I. We close the Excel the for loop. Don't forget the semicolon. And now we can transfer our first parameter. This is done Excel results dot set cell value For that we need the value itself, the sheet index, the row index, and the column index. The sheet index is again the var Excel sheet. The row index is the actual row, and the column index is the actual column plus plus, because we don't want to write the results in the previous column. So, and the value is the value you are going to transfer. If you go back to our simulation model, for example, we have here the measurements for the width, and we want to transfer the average width as first key matrix. So we call the statistic element width, and we want to have the mean value, so we go for the mean. And that's it. So now we have to make sure that we have not generated any mistakes. We have 4 mistakes so far in this model. The first one is that the variable is defined to a double, but the variable should be a string. And we call it table results. So this is the name of the Excel table itself. Now we have to define in the Excel results interface the Excel file where we are going to save the data. In my model, you can see there are a lot of tables, but I'm going to generate a new Excel file, and the Excel file is called results. We save that. So we can see now in the Excel file that we have selected the correct Excel file, which is in this case wrong, because we want to have the file Excel results, and now the file turns from red to green. If we compile it again, we can see that there are no, that in the Excel file the table TB results is not available. So we open the Excel file. I have saved it in the basis model. I open the Excel, and here downstairs I'm going to change it to table results. I'm going to save the file, and I'm closing the Excel file as well. So finally we need 2 quotation marks, and then we can debug again, and we see we don't have any mistakes so far. So finally we have to call the function we have generated here so beautifully. So we click on the main agent. So make sure that you can click here where no blocks or parameters variables are located. Then you see the properties of the main agent. We search for the destroy code, because after the simulation run is executed, we want to transfer the results to the Excel. Therefore, we go to the destroy code and we activate, or we call the function fun Excel write results. After we have done that, we can debug it again. We see we don't have any mistakes. So we run the model. Java applet is generated. We run it as fast as possible, and you can see the average WIP is 1, and we would like to see this 1 in our Excel file. For that, I close the Java applet, and I'm going to open the Excel file again. So I switch to the browser, I open the Excel file results, and we can immediately see that in row 2 the value 1 has been transferred from our Anylogic file to Excel. What you can do is that you can give a header. For example, it's with mean. When we close it again, and when we are going to execute our simulation model again, we run it as fast as possible. We stop it, and we are going to open the Excel file again, and we will have a look on it, and we can immediately see that the new results have been appended to the previous result. Now it's rather easy to include more key figures. For that, we're going back to our function. We go to the function body, and now we just have to copy the last line. We copy it, we insert it. Now we just have to change the value, and in this case we don't want to have the mean width. We want to get information about, for example, the maximum WIP occurring in the system. So we're using statWIP.max brackets. And then we debug it, we recognize no mistakes, and we can execute the model. We run it as fast as possible. We can check the WIP value. The maximum should be 1. We stop it. This is an interesting error, because the problem here is that I have still opened my Excel file, and now the interface cannot be opened again. That means whenever you start the simulation, please make sure that your Excel file results is closed, otherwise you will lose the results. So we close it, we close the Excel as well. So, and now we are going to run the model again. The applet is generated. We run the model as fast as possible. We stop it, close the file. So let's open the Excel file. And we see that we have gotten a new row with the new key matrix, which is now the WIP max. And now you can choose, of course, different statistics elements where you can transfer the mean, the max, or the mean to the Excel file. And of course you can also run your parameter variations, and your results are transferred immediately to the Excel file. For the parameter variation, you have to make sure that you don't allow parallel evaluations, so therefore you go directly to your parameter variation experiment, and you go to advanced, and here you can find allow parallel evaluation. That means that one simulation run is executed on one of the cores of your computer, and if you allow the parallel evaluation, then several experiments are distributed to all of your cores. And here the disadvantage is that, at least in the beginning, they will finish at the same time, but the first one who is opening the Excel connection wins the race and can transfer the results to Excel. And for the remaining simulation runs, they also try to open the Excel, connection, but it's of course occupied, as we have seen in the previous error, and you will lose the results. So please make sure when you run your parameter variation that you disable allow parallel evaluations.